power factor improvement method on that synchronous condenser. Okay, synchronous condenser. So here synchronous motor takes a leading current when overexcited and therefore behaves as a capacitor. Okay, so overexcited synchronous motor is called as a synchronous condenser. Understood? Synchronous motor leading current when overexcited and therefore behaves like a capacitor. An overexcited synchronous motor running on no load is called as a synchronous condenser. An overexcited synchronous motor is running under no load is called as a synchronous condenser. Remember, so what is by synchronous condenser? Means an overexcited synchronous machine. So that means excitation is more than normal. Okay. An overexcited synchronous motor is running on no load is known as synchronous condenser. Remember, synchronous condenser. What is by synchronous condenser means? So this is the when such a machine is connected in parallel to the supply, okay, it takes a leading current which partly neutralizes the lagging reactive component on the load. Understood? When such machines, so this type of synchronous condenser types, this is called synchronous condenser, three-phase synchronous motor. Overexcited synchronous motor is called a synchronous condenser or capacitor is under no load condition. There is no load, there is no load is connected here. Synchronous condenser, this is called synchronous. Overexcited synchronous machine operating under no load is called synchronous condenser. Is connected exactly parallel to the supply or load. So like this. Okay. So in this figure, so power factor improvement by synchronous condenser method. So this is a okay. Three-phase load takes the current lagging current IL. Three-phase load. This is called three-phase load takes the current lagging current IL at low lagging power factor. That is called cos pi L. Okay. So that is called angle between voltage, this supply voltage and this current IL is called pi L. So that is so the power factor is called cos pi L. If the angle is more, because of this cos pi L is less, the load power factor is less. Okay. So if you want to so our concept is want to reduce this phase angle between voltage and IL. So the resultant, if you are introducing this synchronous condenser into the system, then what happens? The leading component coming to the picture, and then the resultant of current with these two is called I. This is called synchronous condenser. Is provide the leading current, and this is current because of three-phase load, inductive load, and then resultant of these two is called this current. That is called synchronous condenser. The resultant current. Then its power factor is decreasing, and then it's not draw more amount of current from the supply. So angle is decreasing means cos pi is increasing. Okay. Three-phase load takes the lagging current IL and at low lagging power factor that is called cos pi. And synchronous condenser takes current IM. Synchronous condenser takes current IM, which leads the voltage by angle pi m. So like this. Okay. So this is called V and it's called pi m. Synchronous condenser takes the current IM, which leads the voltage by angle of pi m. Condenser, it is acting as a capacitor. Na? Overexcited synchronous condenser under no load is called as a capacitor. It is acting as a capacitor, synchronous condenser. So if it is connected like this into the circuit, if it is connected, this motor current leads the current supply voltage by some angle pi m, approximately 90 degrees. Okay. So 80 or 85 like this. So this angle pi m. So because of this, the resultant current angle is decreasing between voltage and current. Okay, the resultant current I is phasor sum of Im and IL and lags the behind the voltage by an angle pi. So like this. Okay, it is clear that pi is less than pi L. So by connecting the condenser, so resultant angle between pi, but without condenser, this is called pi L. It is clear that pi is less than pi L, so that cos pi is greater than cos pi L. Cos pi, this cos pi is greater than cos pi L. Okay, thus power factor is increased from cos pi L to cos pi. Okay, synchronous condensers are generally used for major bulky supply substitutions for power factor improvement. This is about synchronous condensers and also having some advantages. By varying the field excitation, the magnitude of current drawn by the motor can be changed by any amount. Understood? By changing the field excitation. So field excitation is that is DC excitation, that is now hand. By changing the rheostat, we have to control the field current. By varying the field excitation, the magnitude of the current drawn from the motor can be changed by varying any amount. This helps in achieving stepless control of power factor. Okay, and the next one, the power factor windings have high thermal stability to short circuit currents, and faults can be removed easily. These are the different advantages of synchronous condenser. And then disadvantages, also having some disadvantages. There are considerable losses in the motor. So it is a motor. No? Synchronous condenser is nothing but the motor. Over-excited synchronous motor is called as a, under no load condition, over-excited synchronous motor is called as synchronous condenser. Okay. So this called, there is a considerable loss in the motor. There is called mechanical loss extra. Okay. The maintenance is cost is high. Produces noise. Except in sizes above 500 kVA, the cost is greater than the static capacitor for the same rating. Okay. And then as a synchronous motor has no self-starting torque. Synchronous motor has no self-starting torque. Therefore, an auxiliary equipment has to be provided for this purpose. An extra cost. This is called synchronous condenser. Okay.